Welcome to all of you in Sankalp Education Pratham classes. I am Sachin Patil, delivered lecture series on derivative. Right now we are going with the sum derivative of parametric function here. First of all, we have to know about the parametric function. What is the parametric function is here? That means you have to consider x is equal to f of t and y is equal to g of t. What does it mean? That means x is the function of t and y is the function of t. That means there will be, this equation implies functional relation between the variable x and y for a given value of variable t. That means this function x is the function of t and y is the function of t, and that means when we have to change the value of t, then both the value of x and y both are also changes is there. That means there is a functional relation between the variable x and y in between these two by using the variable t is here. And if two variables x and y are defined separately as a function by intermediating variable, that means t is the intermediating variable between these two, and then variable t is called as a parameter. Variable t is called as a parameter, and functions are called parametric functions are there. That means the function that means two variables are given inside the one variable. Two variables are defined in the function of one variable. At that time, this one variable is called as a parameter, and those two functions which gives the functional relationship between each other are called as a parametric functions are here. For example, x is equal to a cos t and y is equal to a sin t. That means a is a constant here, and t is nothing but a parameter. That means value of x is depends on t and value of y also depends on t. That means t is an intermediate variable between x and y. That means it gives the relationship between x and y. How to get the relationship between these x and y is taken as follow. First of all, we have to square on both sides of that equations. That means you will get the squaring. You will get the x square is equal to s square cos square t, and here also squaring, you will get the y square is equal to s square sin square t is here. And now adding these two equation, you will get the consideration of x square plus y square is equal to s square cos square t plus s square sin square t is here. That means here a square is taken as a common, and therefore inside the bracket cos square t plus sin square t, and it is nothing but 1, and therefore you will get the s square. That means x square plus y square is equal to s square. It is a relation between these two variables x and y, and it is nothing but a equation of a circle, and therefore these two parametric equations gives the relation between x and y in the form of equation of a circle. This is your relation between the functional relationship between these variables x and y in the form of a value of variable t, and therefore you will get the consideration of these two are the functions. These two are the parametric functions, and parameter is a t. Right now we are going with the theorem related to derivative of parametric function. First of all, we have to think about the theorem. If x is equal to f of t and y is equal to g of t are the differentiable function of t, that means these two functions, that means x and y are the variables in a t, and therefore x is dependent on t and y is also dependent on t. That means x is a differentiable function of t and y is also differentiable function of t. Then we know that the two variables are given inside the form of one variable, then there will be a relationship between these two variables also, and therefore y is a differentiable function of x. Then, and if dx by dt is not equal to 0, this is the most important, because if denominator becomes 0, then there will be a complete meaningless derivative of that one, and therefore dy by dx, that means derivative of y with respect to x, is nothing but a dy by dx. It is equal to dy by dt into dx by dt, where denominator is not equal to 0 is there. For this, first of all, we have to going with the proof. First of all, we have to get the consideration of proof is here. Let delta t be the small increment increment in t. That means you will get the small change in a value of t. We know that the x is the function of t. That means x is a dependent variable and t is the independent variable. That means any change in a t causes the change in x. Similarly, you will get the y is equal to g of t. Here y is a dependent variable and t is an independent variable. That means when value of t changes, then there will be corresponding change in y also getting. And therefore delta x and delta y be the corresponding increments in x and y respectively. Now we have to get the x is equal to f of t. That means x is the function of t, x is a dependent variable and t is the independent variable. Therefore, derivative of x with respect to t is given as dx divided by dt. It is equal to limit of delta t tends to 0, delta x divided by delta t. It is according to definition of derivative, and according to that definition, limit of delta t tends to 0, delta x divided by delta t is here. Similarly, you will get the consideration of similarly y is equal to g of t is here. That means y is a dependent variable and t is an independent variable. Therefore, derivative of y with respect to t is given as dy by dt is equal to limit of delta t tends to 0, delta y divided by delta t is here. Delta y divided by delta t. Now we have to consider one thing is here, delta y divided by delta x is there. Delta y divided by delta x is there. Now we have to get the consideration like that one, delta y divided by delta t divided by delta x divided by delta t is here. That means we divide numerator and denominator by delta t is there, and you will get the consideration of this one. Now taking limit on both side, taking limit on both side as delta x tends to 0. That means you will get the limit of delta x tends to 0, delta y divided by delta x is equal to, here also limit of delta x tends to 0, delta y divided by delta t divided by delta x divided by delta t is here. Now this limit is taken in the numerator and denominator as, you will get the consideration, limit of delta x tends to 0, delta y divided by delta t whole divided by limit of delta x tends to 0, delta x divided by delta t, now here you will get the limit of delta x tends to 0, delta y divided by delta x is here, and you will get the result of that one. That means in the right hand side you will get the limit of delta x tends to 0, delta y divided by delta t, and limit of delta x tends to 0, delta x divided by delta t. But if delta x tends to 0, then delta t also tends to 0, because if delta x tends to 0 is nothing but a change in x, which is depends on the variable change in t. That means if delta x tends to 0, then also delta t tends to 0 is there, and those changes putting here, you will get the consideration of limit of delta x tends to 0, delta y divided by delta x is equal to limit of delta t tends to 0, delta y divided by delta t whole divided by limit of delta t tends to 0, delta x divided by delta t is here. Delta x divided by delta t is here. Now, if y is function of x, then derivative of y with respect to x is nothing but dy by dx is equal to limit of delta x tends to 0, delta y divided by delta x. That means this value is nothing but dy by dx, and according to that one, first of all we have to think this is equation 1, this is equation 2, this is equation 3, and here you will get the from 1, 2 and 3, you will get the dy by dx is equal to dy by dt divided by dx by dt, where dx by dt is not equal to 0, where dx by dt is not equal to 0, and it gives a final result related to that of theorem. What does it mean? First of all, we have to think about the two variables which are depend on the same variable. That means intermediate variable is nothing but t is here, and according to that one you will get the derivative of x with respect to t and derivative of y with respect to t. Then y is the function of x, then dy by dx is nothing but dy by dt divided by dx by dt. Here first of all we have to think if dy by dx is exist. If dy by dx is exist, at that time dx by dt is not equal to 0, because if dx by dt becomes 0, then right hand side is not existed, or it does not have any meaning, and therefore you will take here dx by dt is not equal to 0. Inside this we will get the parametric function and how they are related with each other, and according to that theorem how to calculate the derivative of a parametric function is taken here, and by using that theorem you can calculate the derivative of different parametric function in the next lecture. If you like that video, please subscribe my channel and press on bell icon to get the next notification related to that derivative lecture series. Thank you.